Hello everyone, welcome. My name is Sebastián Guarino. Today I'm going to talk about how I hacked a Wi-Fi lamp. First of all, a little bit about me. I studied electronics engineer. I also study a bit about embedded systems. And I always work in security-related positions, sometimes building things and other times breaking them. My actual position is Principal System Administrator in Red Hat, specifically in pipeline security. Well, let's introduce a bit what I'm going to show. By lamps, I'm referring to this kind of lightning bulbs. Nowadays, they come with LEDs and Wi-Fi connection, so you can operate them using the vendor application, and also they can be integrated with Alexa, Google Assistant. You can also integrate it with local solutions like Home Assistant and other ones that support it. So I bought a couple of lamps of the same model and brand, and the goal of this talk is to open them after use it and try to retrieve sensitive information from them. After opening it, we can identify, for example, in this model of lamp, it could apply to any other. We can identify a main board, which is the one on the right. It also has a secondary board soldered on it on the top. We can see that secondary board has a Wi-Fi marking there, so that's a clue that something interesting is there. I desoldered it. I also removed the metal case. The readings on the metal case is something that could be interesting for searching things on the internet. And inside the breadboard, we can identify two main components. One is the system on chip, and the other one is a crystal oscillator. The crystal oscillator is a 26 megahertz crystal, and the SOC is a ESP8285 in this case. This is something we are going to use later. By searching the readings on the secondary board, which is the breadboard, I was able to confirm that it's publicly available for sale. I also found the pinout of the device, so this is useful for soldering things there and try to interact with the device. By looking information about the system on chip, the manufacturer provides the datasheet. Is available. And the important thing I found on the datasheet is that it's very similar to the ESP8266, which I'm very familiar with. It uses the same software development kit. It needs a power supply of 3.3 volts, and the power consumption is above the 70 milliampere. Another important thing is that it provides a 1 megabyte flash. All these things we are going to use it later. The only main difference of this device against the ESP8266 is that this device is designed for use in lamps, and it supports more high temperatures because they are very close to the LEDs. Okay, now we are going to cut the wire of the domestic power supply, and we are going to try to power the device using two wires. I soldered two wires in the breadboard, one in the breadboard, and in the case of the ground, I was able to find another more comfortable place to solder it in the board, so no need to do it more difficult. So now we are ready to power the device on. I powered it using a regulated power supply. I was able to confirm that it's consuming like 70 milliamperes. And after a while, a new Wi-Fi network appeared. This is because I shut down the previous Wi-Fi I configured for the initial configuration of the device, and the device is publishing a new network for initial configuration because it couldn't connect to the previously configured Wi-Fi network. So the next step is to solder signals to communicate with the device. The device supports a serial communication. So we need to solder one wire for the transmission and the other for the reception. To communicate with my computer, I used a USB serial converter, which is the one on the right. This type of devices provides from the side of the computer a serial device that is commonly detected for any common operating system. Another thing to note is that the receive and the transmit signal need to be crossed. So the transmit signal on the device needs to be connected to the receive signal on the converter, and the other way with the other two. So I connected the lines, and I use it as an application, a terminal application in the computer, the screen command, which is very common and is available on every Linux distro. For my surprise, I didn't get any output. I tried every common baud rate, but I wasn't able to detect any output. So I was able to connect the oscilloscope to see the frequency of the signal. However, I switched back to the datasheet to read a little bit more about it. And when the crystal oscillator is at 26 MHz, there is a big note on the manufacturer that is saying that the baud rate will be 74,880 BPS. It's a wide baud rate, but it's something that we could give a try. So here comes set serial the rescue. Set serial is a command that also comes with almost any Linux distro that permits to configure the serial driver. And in between these features, it also supports to set a custom baud rate. You need to do some math because you need to calculate how close you can go to the target baud rate, and I was able to set it as 76,000 BPS. And with this configuration, I was able to get output on the serial. So let me get down. Well, here is the output of the console. Some things interesting is that it's confirming that it has a 1 megabyte flash. And there are some readings from the firmware. And one important thing we are going to use later is the software development kit version, which is 3.3. Sorry, it doesn't scroll there, but well, believe me, there is a reading about the version of the software development kit. The last two config lines we need to solder is the enable and the IO0. Those are needed for to tell the device to boot into programming mode. The enable is enable low means reset the device, and IO0 low means boot into programming mode. So the way to use these two signals is keep IO0 low and reset the device by setting the enable low. The way I configured this is I used two push buttons, one for each signal, and by keeping pressed the IO0 low, I just used the other push button to reset the device. So by doing this, there is another tool from the vendor which is called ESP tool, and it comes packaged as a Fedora package. I'm not sure about any other distro. And with this command, I was able to download all the content of the memory in a binary file on the PC. However, when I tried to detect the partitions on the binary file, I wasn't able to detect any partitions. I used to detect partitions on other ESP devices, so I'm not sure about why. Probably it has a custom partition, or it doesn't have a partition at all. I tried also with the winwalk command, which is a very common tool to find things on a binary file. And didn't get any, I got very few results with that command. I gave a try also to the strings command, and that command throws so many results that it's not practice to use it. So I dig a bit more in the software development kit. start reading the exact version that comes with the firmware. And one interesting structure is this one, which is supposed to store the Wi-Fi network name and the Wi-Fi password, between other things. For the network name, the length of the buffer is 32 bytes, and the password is for the password is 64 bytes. So we need to find printable characters with size lower than those. I also put another constraint, which is I'm looking for network names bigger than 4 bytes and password bigger than 8 bytes. Another constraint we can apply here is these structures are usually used as a global variable because it's provided by the operating system, which is the software development kit. And global variables in C are always initialized with nulls. So what we are going to search is network names between those ranges, but they will be null padded till the end of the buffer. And the same for the password. Another interesting structure is this one, which is supposed to store the MAC address of the station this device was associated with. We can apply printable character constraint here because there are 6 bytes arbitrarily, but there is a special byte that follows, which is split into bits, which corresponds to different modes of the Wi-Fi. I put 2 constraints, and we can also set that the second nibble of this byte would be 0. Another constraint we can apply here to limit the results is that the 6 bytes needs to exist in the MAC vendor data list. And lastly, we can check also the MAC address against the Google geolocation service. I put all this logic together into a script, which is publicly available in GitHub. And by running this script against the binary file, the only network name and password it found was the correct one I set before in the testing Wi-Fi network. Regarding the MAC addresses, the script found like a dozen of MAC addresses. However, only one has a valid entry in the MAC address vendor database, and also has an entry on the Google geolocation. And the geolocation corresponds to my home. Side note here is that I'm not living there, so there is no leak. So conclusions. I was able to retrieve the network name and the password from a LAMP. So an attacker could steal a LAMP from an office, and if the LAMP is Wi-Fi, he might probably retrieve the network name and the password and escalate the attack. Another conclusion we can say is that if anyone finds a LAMP in the trash, he may probably also retrieve the network name and the password, but he could also retrieve the MAC address and the geolocalization of the last time the LAMP was used. So don't throw away your IoT devices without erasing them or destroying them. Well, thank you very much. I hope you enjoyed this talk. I'm glad to answer any question if you have. Yeah, sure.
Was the actual light bulb cheaper than the board itself?
Than the port? No, the port, by the port you mean the USB converter?
Yeah,
okay.
€6 USP.
Okay, he's asking if the light bulb is cheaper than the USB serial port converter. No, I think the bulb is, the USB converter is cheaper than the bulb. Yeah, I think the USB converter, if you use a cloned one, no, the original FTDI, it's like $5 or something like that. Yeah, sure.
If you were able to put it in the boot mode, in programmable mode, you probably would also be able to install something under like ESP Home, I suppose, right?
Yes.
Did you try that, or is it something interesting to explore, or you just need it?
Honestly, I didn't try to update the firmware on this specific device. I tried. Sorry,
I customized one firmware for this type of lab, right?
Yeah, yeah. He's asking if I play around updating the firmware or trying another firmware. No, I didn't try with this device. However, I used to work with other firmwares like Tasmota or. Thank you very much.